In this video, we will be showcasing the nozzle selection process for approved John Deere See & Spray nozzles. Here we've listed the approved John Deere nozzles for See & Spray. John Deere makes no guarantees of performance or product efficacy if spraying with other nozzles. The nozzles are arranged from left to right based upon their fan angle width. On the left, the John Deere Targeted Spray Low Drift, or TSL 60, features the narrowest fan angle at 60 degrees. On the right side is the John Deere Low Drift Max, or LDM 120, which has the widest fan angle approved for See & Spray applications. As seen here, a wider fan angle means more nozzle bodies will activate to maintain proper overlap. While this ensures consistent coverage, it also results in more acres being sprayed and therefore less chemical savings compared to narrower fan angles. It is important to note that when See & Spray is targeting weeds, it does not have the option to pulse and acts as a traditional spraying system, relying on speed and pressure. These are the rear-facing John Deere approved nozzles for See & Spray that allows operators to hit maximum See & Spray approved speeds. This chart shows the suggested use cases for each nozzle family. Once again, it is important to ensure that your desired nozzle meets your chemical label requirements. For example, if you are spraying a systemic such as glyphosate and would like to See & Spray cross-row, the nozzles you would choose from would be the 3D, Low Drift Max, and the Ultra Low Drift. When operating the John Deere See & Spray system, one of the most crucial factors for performance is your system pressure. The recommended operating pressure is 30 to 50 psi, or pounds per square inch. Staying within this range ensures the system delivers accurate application, maintains proper coverage, and minimizes drift. When operating within the range of 30 to 50 psi, the system can accurately target weeds and apply the correct amount of herbicide, in addition to reducing the risk of herbicide drift. When operating at a pressure greater than 50 psi, the system will produce smaller droplets, which will result in a greater risk of drift. Smaller droplets also increase the chance of missing the weed entirely, reducing overall application effectiveness. On the other hand, if your pressure is less than 30 psi, the system will create larger droplets. While this poses less chance of drift, larger droplets often fail to cover the weed properly, which compromises your weed control. Now we are going to get into how to size your nozzle for See & Spray. We will start with your targeted application nozzle out of the B-port rear nozzle. This will be the same for all targeted applications, whether you are using a dual product or single product machine. For your targeted application nozzle, you will follow the same gallons per minute formula as you would for conventional spraying. The formula takes your See & Spray rate multiplied by your speed multiplied by your nozzle width divided by 5,940. In this scenario, we are going to use 20 gallons per acre for our See & Spray rate. We will be traveling through the field at a speed of 12 miles per hour, and our sprayer is equipped with 20-inch nozzle spacing. This gives us a value of 4,800, which we divide by 5,940, which gives us a rate of 0.8 gallons per minute from each nozzle, which will require us to use an 08 white nozzle tip. With See & Spray, the operator has the option to run in the mode of A+B, which will allow the operator to broadcast while also using targeted application. Using this equation, we will go through how to size your nozzle for your 8-port nozzle. First, we will take your desired broadcast rate, multiplied by your previously calculated nozzle B tip size, and then we will divide by your desired See & Spray rate. For this scenario, we are going to broadcast 8 gallons per acre. Next, we are going to multiply by our previously calculated 08 nozzle B tip size for targeted applications. Lastly, we are going to divide by our See & Spray rate of 20 gallons per acre. This gives us a rate of 0.32 gallons per minute, which would require us to use an 035 maroon nozzle tip. Utilizing See & Spray A+B will give the operator the ability to pulse out of the 8-port using pulse width modulation, or PWM. To size your 8-port nozzle for PWM, you simply take your already calculated A nozzle and divide by your desired flow rate percentage. For this scenario, we are going to take our previously calculated 0.35 maroon nozzle tip size. Next, we will divide it by our desired flow rate percentage. In this case, we will be utilizing 0.65 or 65% to achieve the best compensation. This will give us a flow rate of 0.53, which will require us to use an 0.5 brown nozzle tip. Now we will walk through a real-world example. We will be applying glufosinate, which is a contact herbicide. It has an application rate of 15 gallons per acre, and the chemical label requires us to apply a fine or medium droplet. We will once again be traveling through the field at a speed of 15 miles per hour, and our sprayer is equipped with 15-inch nozzle spacing. Using the same formula as before, we will take our 15 gallons per acre, multiplied by 15 miles per hour, and multiply by our 15-inch nozzle spacing. This gives us a value of 3,375, which we will then divide by that 5,940, which gives us a rate of 0.5682. Since glufosinate is a contact, we will use the same chart that we previously mentioned, which shows us our suggested nozzles of the John Deere Extended Range, as well as the John Deere 3D nozzle. For this example, we have chosen the John Deere 3D 100 nozzle to ensure that we have ample coverage. If we are prioritizing chemical savings, we could go with the ER80, but in this case we are concerned about coverage. Here we will look to size our nozzle using the application charts found in the John Deere Sprayer Parts Guide. Our first step is to locate the 0.5 nozzle tips and find the closest flow rate to our calculated value. Because See & Spray works best between 30 and 50 psi, we look there first. At 50 psi, we have a flow rate of 0.56 gallons per minute, which has a medium droplet size. We will then find where that meets the rate of 15 gallons per acre to find our speed, which will be 14.8 miles per hour. See & Spray variable rate is different from traditional See & Spray where we are target spraying. Instead, we are using the See & Spray system to detect 2D biomass to apply different rates across the field, giving prescription-like variability in real time. In this scenario, the operator would like to apply at a speed of 12 miles per hour and has their rate set between 10 and 15 gallons per acre. When selecting a nozzle for variable rate, it is important to remember it must be a PWM compatible nozzle. In this scenario, we are looking at 3 different orifice sizes: an 0.4, 0.5, as well as an 0.6 out of our B port only, and comparing the capability for the desired scenario. It is important to note that the operator must set the system to automatic pulsing so that the system can match the desired rate at the desired duty cycle. Here we will look at an 0.4 tip size, which will not reach 12 miles per hour at 100% duty cycle at 15 gallons per acre. We are unable to use this nozzle for this scenario with See & Spray variable rate. Next, we will look at an 0.5 tip size, which is able to reach 12 miles per hour at 100% duty cycle for 10, 12.5, and 15 gallons per acre. This would allow us to use an 0.5 tip for See & Spray variable rate. Lastly, we will look at an 0.6 nozzle tip size. Since the 0.5 tip size works, we can assume that the 0.6 tip size will work as well. However, your droplet size will be affected. Once again, please refer to your chemical label for correct droplet size instructions. Thank you for watching this video on See & Spray nozzle selection. Please check the description for more linked resources to size your nozzles. For more information on See & Spray, please contact your local John Deere dealer.